Okay, good day, grade 9s. I trust that you are well. This short video is just a mere recap of what we did during the term. Please note that this revision lesson does not cover everything that we have done. You still need to go through the revision pack and the content done throughout the term. However, let's just quickly recap on what geometry is all about. So there's different types of geometry. There's analytical geometry and Euclidean geometry. So analytical geometry is basically geometry of straight lines. That's what we call it in grade 9. And when it comes to geometry of straight lines, there's different concepts that you learned about. For example, let's do example 1. Let's say I ask you to solve or to find the value of x. So solve for x or to find the value of x would have actually been worded, would have been a better way to word it. So let's say I have a straight line and I have another straight line. And these two lines are perpendicular to each other. They intersect at 90 degrees. Now I add a partition. So this angle is 90 degrees. Now I add a partition, meaning I add a separation, right? A ray that separates these two, this angle. And the small angle, let's say it's 20 degrees. And let's say the remainder angle is x. So when I add x and 20 degrees, what will it give me? Yes, it will give me 90 degrees. So I'm going to take x plus 20 degrees. It's equal to 90 degrees. And your reason is adjacent complementary angles. I might say, what does adjacent means? Adjacent means one next to another. And complementary angles are angles that add up to 90 degrees. That being said, all we need to do is just solve the equation. X is equal to 90 degrees minus 20 degrees. X is equal to 70 degrees. So this was the content that we looked at in grade 9, and we started off the topic looking at this. We also learned about angles on a straight line. So let's say I have a straight line. So this angle on the straight line is 180 degrees. So you can take a protractor and you can measure the angle on the straight line, and it's 180 degrees. Now this angle is cut into two. Let's say this angle is x and this is 160 degrees. Right? It's a fairly simple example just to show you, or just to recap the point, that I know that the entire angle on the straight line is equal to 180 degrees, meaning that when I add these two angles together, it is supplementary. It adds up to 180 degrees. So x plus 160 degrees is equal to 180 degrees. And the reason for that is angles on straight line supplementary. Angles on straight line supplementary. So I have x is equal to 180 degrees minus 160 degrees. X is equal to 20 degrees. And this makes sense because 160 degrees plus 20 degrees gives you 180 degrees. That is the angle on a straight line. Now, that being said, we also looked at angles around a point, about a point, or angles in a revolution. Now we know that angles in a revolution adds up to 360 degrees, right? That's one entire revolution. We also looked at vertically opposite angles. So let me quickly do look at an example of a vertically opposite angle. So let's say I have a straight line, right? It has to be straight. If it's not a straight line, then those angles are not vertically opposite, and it intersects with another straight line. So if you can recall, the word intersect means that, right, they cross each other at a specific point. This point is known as the point of intersection. So let's say we have angle A, right? And here we have 80 degrees. Again, this is a fairly basic example. I'm just teaching you the concept, and then you can apply it and form equations depending on the level of difficulty of the question. But for today, I'm just recapping this grade 8 concept with you very quickly. So I can see that since these two lines intersect each other, they form four angles. And with these four angles, the angles that are vertically opposite each other are also equal to each other. So A is equal to 80 degrees. So I have A is equal to 80 degrees, and the reason for that is vertically opposite angles. Right, so those are the basics that we looked at. But in geometry of straight lines, we also came across parallel lines. Now, if you can recall, parallel lines are, if I take a point on one line and join it perpendicularly to a point on another line, it is equidistant to all the other points if I do the same. Meaning that if I have two lines, just gonna take this up, if I have two lines, right, and they go in this direction, they will never meet each other. They will never intersect each other like in the first graph or in the first lines that I have drawn, right? These are known as parallel lines. And whenever you see parallel lines, whether it's in geometry or straight lines or geometry of 2D shapes, what should come to your mind is fun, right? The concept fun. Now you might say, what does that mean? F-U-N. So if this is a straight line and it's cut by another line. Now, a line that cuts, now listen to this very carefully, it's very important. A line that cuts two or more other lines are known as transversals. So a transversal is a line that cuts two or more other lines. And we looked at that in class as well. So let's say this angle is parallel, sorry, this line is parallel to this line. Corresponding angles are equal to each other if the lines are parallel. If the transversal cuts parallel lines, then the corresponding angles are equal. Corresponding angles mean that they correspond. They lie on the same side of the transversal and the same side of the line. So you can see that this dot lies to the right of the transversal and below the line, and this dot lies on the right of the transversal and also below the line. So let's call this A, B, C, D. So I can conclude that this angle, which is, let's call it angle BAC, is equal to this angle ABCDE, right? Let's call it angle DCE, and the reason for that is corresponding angles. And again, whenever you write something out, or whenever you write the reason corresponding angles, you have to state the parallel lines. If you do not state the parallel lines, then you do not get a mark for the reason. So again, you need to state the parallel lines. So it's AB parallel to CD. Now the U shape means corresponding angles. So sorry, co-interior angles, not corresponding angles. We already looked at that, right? Co-interior angles, we have X and we have Y, for example. Now, co-interior angles are not equal to each other. When the transversal cuts parallel lines, co-interior angles are supplementary. They add up to 180 degrees, meaning that X plus Y, so let's say this is A, B, C, D, X plus Y is equal to 180 degrees, and the reason for that is co-interior angles AB parallel, so this line AB is parallel to CD. Right? And the last case, we have what we call alternate angles. Now, when the transversal cuts parallel lines, alternate angles are equal to each other. So let's call this A, B, C, D. Right? I can see that if AB is parallel to CD, the transversal is cut in parallel lines, then these two angles are equal to each other. So angle BAD, that's BAD, this angle that's formed here, is equal to angle ADC. ADC. And the reason for that is alternate angles. So co-interior angles basically they lie on the same side of the transversal and between two lines. They sandwich it inside. And alternate interior angles, because you also get something called alternate exterior angles, it's on the outside of the line, on the other side of the line. But alternate interior angles, they lie on opposite sides of the transversal, but between the lines. They also sandwiched in the lines. And again, you need to state the lines that are parallel to each other. Right. So now we're going to use this concept to actually solve some geometric problems. So they could give you a problem, let's say, like this. Right, so I'm going to use my ruler if there's space here. Right, and I'm going to scroll it up in a minute or so. Let's say I have this straight line, and I have another straight line. Right, I have something that looks like this. Just bear with me for a second here. Right, so let's say I have a figure that looks something like this, and I have A, B, C, D, and E. And I'm actually given that line BC is parallel to line DE. I'm given that these two lines are parallel to one another. And let's say this angle here is 20 degrees, right? Let's say this angle here is, let's say it's, let's say it's 60 degrees, right? And let's call this X. And I ask you to solve for X, right? So again, whenever you see parallel lines, the spark in your head should be, is this co-interior? Is this corresponding, or are these alternate angles? In this case, I can see that there's an N shape. Right, so don't feel shy to just turn your page around, and you can see an N shape or a Z shape that is formed. So this is the Z shape that is formed. I just outlined it with my red pen, and I can see that X is equal to 60 degrees. Although this 20 degrees is given, you don't have to use everything in the diagram that's given. You only need what's important to find the angle that you're looking for. So X is equal to 60 degrees, and the reason for that is alternate angles, and the lines that are parallel is BC parallel to DE. Right? So again, they could give you different geometric figures, and you have to solve it. Now, moving on from there, let's look at another example. And this time it has to do with the geometry of 2D shapes. So just an outline, geometry of 2D shapes will include triangles. So you have to know the different types of triangles. An equilateral triangle, all sides are equal, all angles are equal to 60 degrees. An isosceles triangle, there's two equal sides, and angles that are opposite equal sides are equal. Very, very important, even in geometric figures as well. You need to know the angles in an isosceles triangle. It's not just any angles are equal, the angles that are opposite equal sides. And lastly, a scalene triangle, of course, does not have any equal sides, nor does it have any equal angles. So let's look at a couple of more examples. So they could give you geometric figures. You have to know that the sum of angles of a triangle is equal to 180 degrees. We investigated that in class. And of course, we also investigated the exterior angle of the triangle. So the exterior angle, we concluded that the exterior angle is equal to the sum of the opposite or the interior opposite angles. So let's say I give you a geometric figure that looks something like this, right? So I have 3x, I have 2x, and I have x, and I ask you to solve for x. Now, by instinct, you can see that 3x is the exterior angle, meaning whatever this angle here, whatever is the size of this angle, the red dot, plus x is equal to 3x. What I can do is I can use the sum of angles of triangle, and I can find the red dot. I know that the sum of angles of triangle is equal to 180 degrees. So I can find this angle in terms of x, and I can say that this angle plus x is equal to 3x. That's a very long and complicated method, and sometimes when we look at a diagram, we want to first do the complicated method. But if I look at this, I can clearly see that these are angles on a straight line, something that we looked at in grade 8. So angles on a straight line are supplementary. So I can take 3x, that's this angle on the left, plus 2x, that's the angle on the right, and it's equal to 180 degrees. And the reason for that is angles on straight line supplementary. Angles on straight line supplementary. Now let's solve for x. So I have 5x is equal to 180 degrees. I divide the left hand side by 5, the right hand side by 5. X is equal to 36 degrees. right? And it's as simple as that. Now let's look at the last example for the day, and then you can continue with your revision. Let's use a new page actually, so it looks nice and proper. So the question states that we need to find the value of x. Right, so I'm given a geometric figure that looks something like this. Right. So let's say I'm given a triangle that looks something like this. I'm given that this is triangle ABC. The entire triangle is a triangle ADE. I'm also given that BC is parallel to DE. This angle ABC is 5x, and this angle on the top, which is BAC, is 2x. And I'm also given this angle, which is E, which is angle AED, which let's say it's 30 degrees. And I'm required to solve for x. So this is a very fun question, right? It's fun because there's more than one way you can actually solve it. Now, the first thing I saw when I looked at this question is that I can find the value of d. Remember, whenever you see parallel lines, you need to start thinking about corresponding co-interior and alternate angles. Angle D, which is ADE, is equal to this angle, ABC. So why? Because they corresponding angles. There's an upside down F shape that looks something like this. Right? It is an F shape, but it's just orientated weirdly. So angle D is also equal to 5x. I might say, what other ways could I have solved for x? And then I can use, of course, sum of angles of the large triangle, because there's a large triangle here. You could find the value of angle ACB in terms of x. It's 180 degrees minus 5x minus 2x, which is 180 degrees minus 7x. And once you found that, you can say 180 degrees minus 7x is equal to 30 degrees because they're also corresponding angles. Right? So you can see that there's different ways you can do geometry. And that's the beauty of geometry, that there's more than one way you can actually get to the correct answer. And I'll still mark it correct, or the examiner will mark it correct either way. So firstly, let's do the first method that we have seen. We found angle D in terms of x. So we said that angle ADE, that's this angle here, is equal to angle ABC. And the reason for that is corresponding angles. Which lines are parallel? BC is parallel to DE. So we can clearly see that this angle is also equal to 5x. Now I can look at the large triangle, triangle ADE. I can say that 2x plus 5x plus 30 degrees is equal to 180 degrees. And the reason for that is sum of angles of triangle. If you want, of course, if you just write sum of angles of triangle, I will understand which triangle you're referring to. But if you want to be fancy, you can just say triangle ADE, referring to the large triangle. So sum of angles of triangle ADE. So now we just solve for x. I have 7x is equal to 180 degrees minus 30 degrees. 7x is equal to 150 degrees. Divide both sides by 7. X is equal to, and let's see what this will give us. So this gives us a decimal amount. So depending on the question, if it says round up to one decimal place, you leave the angle in the decimal place. If they say two decimal place, you look at the third digit. If the third digit is 5 or more, you round up. If it's less than 5, you keep the second digit as is. But do not round off to the nearest whole number, right? Because, for example, the answer is 21.42857, and that is not the same thing as 21 degrees. You cannot just round off to the next whole number. So I'm going to keep it to two decimal places. But again, read the question, read the instructions before you read or before you answer the paper. So x is equal to 21.428, and because 8 is greater than 5, it's 5 or more. This changes, the second digit changes to 3. So it's 21.43 degrees. That is the value of x. Right, okay. So all the best, grade 9s, for tomorrow's paper, and I hope that you revise your work accordingly. Thank you.